All right, I want to welcome you to another video. This video is going to be about arrays. Whenever you hear the word arrays, probably the best thing for you to think about is like a list of items. Generally, they're of the same data type. It means that you'll have like an array or a list of like integers, or you could have a list of strings or a list of floats or some other data type. Here they use some fancy words saying that an array is an ordered random access collection data type. What it means is that the items in the array or list are ordered. It means that every time you look at it, it's in the same order after you define an array. And random access means that you can access any element at any time. Means that you could access the last element, the first element, or some element in the middle. Some data types you may have to access like the first element, or and then you do something with that element and then you grab the next element, and so arrays aren't like that. So that's why we use these fancy terms like ordered random access collection data type. Right at this time, the thing that you need to be just focusing on is that it's a list. It's a list of items. With Swift, there's several different ways of declaring an array. Probably the easiest is the first one here, the one I'm getting ready to highlight. So what this is going to do is it's going to create an array or a list called array of strings, and it's going to be and it's going to hold a bunch of strings is really what it's going to hold, since we've got string right here. Now we could, if we wanted an integer, an array of integers, we'd put int here. So what I'm going to do, and this is actually an empty list. So this creates the list and it sets it equal to an open bracket and then a closed bracket. That just means an empty list. So if we go over here to this, I paste. Let's say I print array of strings, just to give you an idea of what it looks like. Okay, I spelled something wrong. Okay, array of strings, plural. Okay, as you see, it's just an empty list. There's no items in it. One thing we can do is, if there are times to where you may know what elements you want in your array or your list. This is an example of creating another array, and we're going to set it equal to the items 2, 4, and 7. So let me copy and paste this here. And what I'm going to do is, instead of typing that long name, I'm just going to set this equal to A. I'm going to print out A. Notice here it contains items 2, 4, and 7. Well, the next thing you may think is, well, how can we access those elements? Well, that's the first thing that we do here. Swift is a C-based language. In almost all C-based languages, whenever you're dealing with like integers, whenever you're dealing with with arrays, they're what they're called a zero-based index, which what that means is that the first element here, you access that by, this is at the 0th location, the 4 is in the first location, and the 7 is in the second location, actually. So the way to reference this, let's say we print A there, but let's say we want to access the first element. The way to do it is use a square bracket, 0, and then the close bracket like that. That will say the first element in the array, which is the item 2. So if we print this out now, it's going to print out A, which is the whole array, and then print A sub 0 means that it's going to print out the first element here. Notice that's a 2. If we want to get the next element, we put a 1 there. We'll click run, and it'll print out 4. The reason behind this, the reason why this is this way is since it's C-based, the way that it deals with arrays, C is a little different than Swift. And the way you could access these elements in C would be something like this. You could actually do this. I think you could just do that, which what this refers to, this gets into pointers and stuff like that, something that's actually beyond what we're doing. But actually what we want to do is we want to do this. What happens here is what this would mean is point to the array, the memory location where A is in memory, and then add 0 to it, which means that it doesn't add anything, so it points automatically to the first memory location. When you say A plus 1, it actually knows then to go to the beginning of the array and add 1 byte to it, which means, or 1 data element, which it knows to go here. That's why this is the way it is. I don't expect you really to understand that. You won't be tested on it, but that's just a history lesson about why this is a 0 for that location for where 2 is located, and 1 is where the 4 is located. I don't want to spend a lot of time on that because there's about 4 or 5 pages of notes. There's a lot of stuff we got to cover, so I don't really want to spend a lot of time on it. Then to be able to access this, the last element here, we go 0, 1, 2. So we know now that's going to output the 7. So there it outputs all of the elements. So let's look at a different data type. Since we just did this way up here, it sees all of these as integers. And so it just says, okay, these are going to be a type integer. If we want to use something else, actually, these are really small integers, so we could do the same thing like this. uint8, just to remind everybody what that means. Let me go ahead and get rid of this. Just a little review lesson here. uint8 means that it's an unsigned integer. It means that there's only positive values, and it's using 8 bits, which means that it can only hold values between 0 and 255. So that's what uint8 refers to. It's just the values between 0 and 255. Since all of these values here are between 0 and 255, we could write it like this if we wanted to. An integer, whenever we did the let A equal whenever we did that, Swift will look at this and it'll say, oh, well, these are integers. Even though these are actually unsigned values, it doesn't make that assumption. It just says, okay, these are ints. And so whenever it declares A, I think like that. These two statements are exactly the same. So this and this are exactly the same. We just don't put the int there, and it just defaults to that. So this is shorthand for this. But if you don't want integers there, if you want to use some other type, you'd write it like this. Now, the vast majority of the time, this right here worked perfectly fine. I just want you guys to know that this is possible. And if you look at some Swift code, they may do something funky like this. And I just want you to know how to read that, how to understand what that really means. Because you will see this from time to time if you're looking at code, looking at Swift code. So go through some of these other examples here and look at some of these. All of these are equivalent right here. You could write it like this, which is my favorite way of doing it. I think this is much cleaner. You could write it like this if you want, and that's okay. It could be written that way, and you may see it that way. Or what you do is you define one of the elements, like the first one, as a uint of 8, and then it knows to do all the rest of them that way as well. One little exercise you could do here to see if this first one up here works. You know how I said this is a value between 0 and 255? Try something weird, like let's make this a negative number. -4 is not a uint of 8. It's not an unsigned integer. So whenever we run this, we should get an error. Okay, notice here, it says that negative integer -4 overflows. It means that it's not a uint of 8. It doesn't know how to deal with that, so it complains. Another thing we could do is we could try to put in another value. Let's put in 256, which isn't between 0 and 255. It should also complain there too. It says it overflows. In other words, it doesn't know how to contain it in an unsigned of 8 because it's out of that range. So that's a good little exercise to do. Maybe try some different values and see what happens. If you need an array with repeating values, in other words, if you need like an array with a bunch of 0 values, or it needs to contain some other values, there are a couple different ways of writing it. You could write it like this, hard code it out. And for just a couple of values, this makes sense to write it this way. Of course, you could also write it like this, where you say array repeating example, and you say how many times. So if you need like 20 of them, instead of writing it like this, you could write it like this and then replace the 3 with a 20. I'll leave that as an exercise for you to do on your own. I'm just letting you know that that's possible to do if you need it. Also down here, let's say so far we've just talked about simple one-dimensional lists. Let's say you need something bigger than that. Let's say you need a 2D array, something like a matrix, something like that. So in this example, we can create a 2x3 array by writing it like this. Notice that this is a list in itself, 1, 2, 3, and so is 4, 5, 6. So if you see this kind of syntax, that's what it means, that this is going to be a two-dimensional array. And the way to access individual elements is to add on another dimension here. So you got like your row, and column. So you can access 0, 1. So this is the first element here. So this refers to the 0. And then within here, this refers to the first item, which is what this one refers to. So here's another exercise. Put in this array into Swift and try to access different elements and see what you come up with. If you need other multi-dimensional arrays, you could also use the array function like what we saw before and do a repeating. You can do that as many times as you want. So this creates like a 3D array, 3x4x5 array. And you can do some funky things with that if you need to. I just want to let you know that that's there, just in case if you see that. So far, we've talked about arrays that only have one type. One of the things that Swift allows you to do is to be able to put different types in an array if you need it. And one way to do that is here where we would put the data type. We just put any here. And so what that means is that we can put any data type in here that we want. So here's an integer, here's a string, here's another integer, here's a Boolean, here's another string, and then here's an integer. So we can take this if we want, and we can copy it into Swift, and let's just print this out just to see what happens. See, it prints this out, so it's possible to do that. Let's say you've got an array with a bunch of different types. Let's say you just want the integers, for example. So you want 1, 2, and 3. You don't want anything else. There is an array function called flatMap, and that allows us to be able to extract certain elements out. So if we run this, it does complain a little bit. Okay, actually for this version of Swift, it's saying that flatMap is depreciated. You'll see this from time to time with compilers. As the compilers, people add more things, they'll start changing the language a little bit. And so this is something you do need to be aware of. And right now, all it's doing is just throwing out warnings. Eventually, this is going to cause errors. And so everywhere in here where we've got flatMap, we probably want to change that to compact map. It even tells us here what we need to do. Use compact map. So if we do this, let's see if it'll work now. Okay, there we go. So you see here, this refers to give me the element as an integer. So what it does is it tries to see if it can take this value and convert it to an integer. If it's an integer, it'll return it. If it's not an integer, it'll not return it in our new list. So notice that numbers here only contains 1, 2, and 3. Now let's get a little creative here. Let's start experimenting a little bit. One of the first things that I think of is, well, what about a string that is actually a number? So let's say on the end here, let's make a string and let's say that it's a 4. It contains an integer in the string. Will this return 4 on the end here, or will it just leave 1, 2, and 3? So we can see here what compact map does. Does it take each value here and see if it is just an integer, or does it try to convert it to an integer? Because sometimes, if you remember several lectures ago, whenever we were talking about data types like integers, numbers, stuff like that, there are functions that will try to convert a string to a number. So let's see what this does. So let's click run. Okay, it doesn't. So what this does then is it checks to see if the number is an integer, is of the integer type, not can I convert it to an integer. So since the number here 4 is a string, it does not get returned. It checks to see what types, what values are integers. Okay, moving along. Let's say we want to get an array of elements out of here. We don't just want to access a single element, but we want to get maybe the items in the middle of it. And we don't want to reference each item individually. One way we can do that is, let's say we got all these words here and we want the items in the 2nd through the 4th location. So we got 0, 1, 2, 3, 4. So we want these 3 items. So by we can access those by saying 2 and 3 dots 4. It means from the range of the 2nd item at the 2nd index to the 4th index. So now if we print out slice, let's see what we get. Okay, it outputs these 3 items like what we had before. see what happens if I try to access a certain item in the array. Let's say I want to try to access welcome. Let's see what happens. Will this return welcome, or will we get some type of an error? Okay, what did it do? What did it do? What did it do? Print slice. Okay, this is kind of weird. I'm expecting 2 print statements, but it only returned 1. Okay, this is weird. I'm not sure what's going on. Let me try this. Let me try it all over again. Okay. That is weird. It should be trying to print something, but it prints nothing. What about if I try to do that? Okay, it's like as if it's not printing that at all. Let's try putting something down here, see if it'll go that far. Okay, it's not even printing the hello, so something weird is going on here. There might be some kind of a bug with the compiler that it doesn't want to do this. The reason why I brought this up is if you look at what I've got going on a little further down here, is that whenever you try to reference something like words 2 to 4, slice is not really an array. It's actually an array slice. This is where Swift really, I think, goes off on the deep end. I think it's making things more complicated than what it needs to be. I think it should just return an array, because really that's all that this is. This right here is just really another array. I think eventually Swift will do that, because I don't see really the advantage to doing what they're doing here. So let's try doing what we got down here further in the notes. Let's try to convert the array slice to an array like what we've got here, and let's see if it will work. First, start off by just saying result, see what it does. Okay, now it's printing everything. Now if we print 1, what is it going to do? Should print out. Okay, so it's printing out what I expect it to. Really, notice what we saw going on there. The compiler is doing something kind of funky. It should have given us an error. It should have done something. Instead, it just did nothing, which is horrible. Shouldn't do that. Hopefully, by the time you watch this video, they fixed this bug. So if your results are slightly different than mine, that's probably what it is. The version of the compiler you're using is probably a slightly more modern, more current version. And so if you do get slightly different results, that's okay. It's probably a good thing, especially in this case. Because notice here what we had to do to get the results that I expected to get. If you just tried to print out slice, like what I did here, which is what I would expect to do, I would expect this to return, okay, it's these 3 values. So once you get these 3 values in slice, the first item then should be welcome, which is what we got here. But whenever I run this, it just does the first print and then it does nothing below it. So something weird's going on. Something weird. So that's okay though. Let's continue on. Whenever you've got an array or a list of items, quite often you want to sort those. There's a couple different ways of doing that. Swift has 2 functions, one called sorted and the other one called sort. I actually wish that they didn't do that. I wish they only had one sort function, but they don't. Whenever we do this, we're first going to print out the original list and then the sorted list. So what happens here is sorted, this function sorted, takes the items in words, sorts them, and then puts them in sorted words. And it leaves the sorted array alone. Notice down here whenever we print out words, what is printed out here, hello, bonjour, salute, aloha, is exactly like what we had up here. So this function does not modify the original array, but returns an array of sorted items, which is what we see down here in sorted words, which is this second printed item. Okay, to complicate things even further is that we've got a function called sort that will sort the items in place. So now let's run this. Okay, this is why it's complaining. Well, let me see. Okay. Let me explain what's going on here. Why we get this error. Sort will try to sort the items in the array words. Sorted, on the other hand, takes the items that are in Word, sorts them, and then puts them in this other variable. Sort does not do that, while sorted does. What sort tries to do is to take the array here and just sort the items in place. And so that's why we're getting the error here. It says cannot use mutated member of immutable value words. Words is a let constant. In other words, what it's saying is that the values in words, these values in word, this array cannot be changed. That's what let does. Remember, it's a constant. But if we change this to a var, it should work. Okay. The first print prints out the original values for word. The second print is for sorted function, and the third is for words. And we get, notice that the result is the same, but the difference between sorted and sort is that sorted will take the items from an array, sort it, and place it into another array, and the original array is not changed, is not modified. Sort, on the other hand, will sort the items in the array. And that's what it does, as we can see here. I don't know why it has two functions to do that, to pretty much do the same thing. There's ways around this program. There is a little bit of typing you got to do, but I don't see any reason. A lot of other languages that I see don't have two functions to do the same thing. I just want you to know that those two functions exist, and that if you need to sort, those are the two different ways that you could possibly do it. You do need to know the difference between the two. That could be on an exam. Filtering an array. Let's say you've got an array like the following. Let me go ahead and get rid of all of this. There's ways to be able to get certain items out of an array based on certain characteristics. Let's say we've got an array of numbers or a list of numbers. So we've got 22, 41, 23, and 30. And what we want to do is we want to find the even numbers out of here. Well, there's a couple different ways of doing it. One way of doing it would be to write a for loop. Let's do this. Let's say I can say, let's say var a int equals the empty list. And then what I could do then is I could sort through my array And this is something we haven't talked about just yet, but I'll go ahead and do it anyways. For item, I think this is the syntax. Hopefully it's right. If it's not, we'll figure it out. If item mod 2 is equal to 0, append item. Okay, this is probably going to throw an error. Let's see if it does. No, it doesn't. Okay. Oh, what's going on here? I may have to come back to this example after we talk a little bit further. As we get the empty list, why are we getting that? No, it's not item in A, it's item in numbers. I'm sorry. We're wanting this list. See, I'm doing this on the fly, and that's what happens. Let's see if this works. Okay, it works. There's a reason to my madness. This code here is equivalent to this one line on 13. And so instead of, this is something that quite often happens whenever people write code. There's a lot of things that you do over and over and over again. And so sometimes we'll write little quicker functions to do it that's a little more efficient. It's easier to read. You can do it on 1 or 2 lines instead of having to write all the code. So since what I got highlighted here is equivalent to what's on 13, notice what we got here. This is a filter function, and what it does is it checks to see that the item, that's what the $0 means, is that each individual item divided by 2 is equal to 0, not divided by 2, but remainder modulus 2 is equal to 0. So this right here is equivalent really to this if statement here. Here we're checking for each item in the list. Start off with 22. If 22 mod 2 is equal to 0, it does. We add it to our list. That's what append item does. And then we do that for each item in the list. Next one is 41. 41 modulus 2 is actually has a remainder of 1, not 0. So we skip over that one. Same thing with 23. And then 30 is an even number. This will return true. And so we add it to A, and then we output it. Notice that here's 5 or 6, 10 lines of code to do what we could do here on 1 line of code. So what's here on 13 is equivalent to from 5 to 10. What'll happen here is there's a couple reasons why we want to do it this way, using the filters function. One, it only takes 1 line of code, as we see here. And then also the compiler sees this, and it knows it can make certain optimizations to make it run faster. And so by doing it this way, you can write cleaner code, more efficient code. Now, there's nothing wrong with this except that it runs just a slightly little bit slower, and it takes a little bit longer to read this to see what's going on. Both of these solutions are perfectly fine. And if you're wanting to do something else in here, a different test, or you need to do some other work here, then maybe this first solution here is the best way to go. But if you're just checking to see, like in this example, you're just wanting to get all the even numbers, you might as well just go ahead and write it like this. But if there's a lot more complicated stuff you need to do, then this may not be the right solution. So you got to look at it case by case. One thing about this example, it's a little premature, is because later on I think we do talk about if statements, and so I'm actually showing you an example ahead of time, and then also the append. We haven't talked about it yet either, and that all the append does is add an item to the array. So it just adds it on to the end. Since we start here, this is an empty list. It'll just add it to the end of the list if the item meets this criteria. Now, if we remove this, would then take each item that's in numbers and put in A. So actually A then would equal this whole array if we did this. And I'll leave that as an exercise for you. You can do that yourself. So maybe try to put some other values in here and numbers, see how it prints out. Maybe change this to a 3 or a different value and see what happens. Change it to a 1, change it to a 2, change it to some different values. Maybe change this to a 1 and see what happens. If you do that, you'll get all the odd numbers. So the 0 will be all the even numbers, 1 will be the odd numbers. Because whenever you take any number, divide it by 2, the remainder's always 1 or 0. There's no other value you could have. So let me move on. I'm actually going to skip a little bit of stuff because this video is starting to get long, but feel free to go over these. This actually just shows you how to take integers, for example, or an array of a certain type and convert it to a different type, which is sometimes handy. So this takes an array of numbers and converts it to a string that contains numbers. So this is a string, 1 is a string, 2 is a string. Here's a way of taking some numbers and multiplying each item by 2 by using the map function. Just an efficient way of writing another for loop. Did we talk about for loops in here? No, we don't. I think we actually talked about them while we were talking about loops slightly. So I guess I don't get to that here. Some other useful array functions. You can check to see if an array is empty with the isEmpty property. So I could go up in here and let's say print even numbers is empty. This should return false because even numbers has 22 and 30 in it. So let's run this. Notice that it returns false. So you can check to see if an array is empty or not by using this property. And that is very handy. You'll use that a lot. You can reverse the items in an array. So let me actually start with numbers equals 1, 2, 3, 4, 5, which is what I had in the examples. If we print out the reverse, it'll print out 5, 4, 3, 2, 1. Oops, I need to put a bar there because it sorts them or it reverses them in place. Now, what's going on? Oh, I know what I did wrong. Instead of doing a print here, since it does them in place, I need to print out the numbers below it. And then it'll print out 5, 4, 3, 2, 1. So that's a common mistake that people make. Remember, we already talked about sorting an array. We have sort and sorted. Sort will sort the items in place like what we see here. So if we print out array, it'll print out 1, 2, 3. Some other useful functions for arrays is the max and the min. Let's print out the numbers. They'll be in reverse order, and then I want to print out what min does is it will return the minimum number in the list, and max will return the maximum number in the list. So we run this. Conversion from int to any. Okay, it actually will return 1 and 5. What it's complaining about is provide a default value to avoid this warning. So what you could do in here is you can put in a default of like 0. And what that'll do then is if it returns 0, then you'll know that must to call that have no parameters. Okay. Okay, what it does then is it prints out optional 1 and optional 5. I think what we can do, if I can remember properly, yeah, this will print out 1 and 5. We put this bang or exclamation point at the end. What that does is it forces it to return the optional value, which we know then will be 1 and 5. We can also add arrays together. Let me see, where 6 onwards. Okay, let's see what's going on. Let me go back here. Grab all of this. Grab everything, that's okay, I can fix it. Okay, so we start off with an array called example array. It contains values 1, 2, 3, 4, 5. We can append on a value. Remember we talked about append a minute ago with the filter. This will add 6 onto the end. And then we can look at sometimes you want to add 2 arrays together. In other words, you want to have one array and then add another one onto the end. We can write this a couple different ways. So let's create another array called 6 onwards that'll contain values 7, 8, 9, 10. We could actually write it either way. We could write it like this. These two are equivalent. Whenever you have the plus equals, it means to take whatever's in here and add this onto the end, or you could write it longhand like this. So what I will do is I'll print out example array, and I will comment out one of them, and this will then contain the values of 1 through 10 that way, because it just adds the values onto the end. Or we could do it with a shorthand, and it has the same value. So you could write this either way. If you want to write it long ways like this, that's fine. This is a shorthand way of writing it, but you need to be able to read that and know what it's doing. You need to understand what it's doing. So that's about it, I believe, for today. Let me just double check. Okay, nope, there's one more thing. And these are kind of important too. We've talked about adding stuff to arrays, all that kind of stuff, but we haven't really talked about how to remove items from the array. So let's look at this. So to make this a little easier, let me go ahead and 7, 8, 9, 10. So that way it's kind of a self-contained example. Example array will contain all the elements from 1 to 10 in order, as you can see here. And we want to remove an item at index 3. So this is 0, 1, 2, 3. Remember, we start at an index of 0. And so the item that we will be removing is 4. So example array then should equal what we see here. And then if we want to remove the last element, it would remove the 10. It figures out how long the array is and automatically removes it. If you want to remove the first element, it'll take this first element and remove it. So it adds some functions here for us to make it a little more convenient. Because especially the remove first, that one isn't absolutely necessary because we know that remove first is equivalent to remove at index 0. This is a little cleaner, but these two statements, remove first and remove at index 0, are pretty much equivalent. The remove last is a little bit more difficult because we don't know exactly what the length of the array is, but that's possible to do too. And I think to find the length of the array, it's just example array, and we've actually seen this before. I think it's just count. So let's do that. Let's do this. Let's see what happens when we do this. Let's also print out example array after we remove the item at index 3, remove the last item, and we remove the first item. We should come up with an array that looks like this here. Let's see if that's really what happens. We can also see what the count is. The count should be 1, 2, 3, 4, 5, 6, 7. So let's see if that's true. All right, error value int has no member, remove at index. Ooh, they've changed it. Okay. Swift has changed their array functions a little bit to where this is not valid anymore. That's interesting. I will have to look that up. Sometimes these compilers will change, especially whenever they're new. Whenever they're a younger language, they're still trying to figure out exactly what the feel of what the language should be. And in earlier versions, the remove at index was there, but with this current version that we have, it's not. I will have to look that up and figure out why that's not working. Let me just try remove and let's see what happens. Okay, all right, okay. Missing argument label at in call. Okay, so what I need to do then is say remove at 3, and that should then be equivalent to what we had before. So let's see what happens. Okay, it did what we needed to do. So what happened here is that in between the version that I wrote the notes and the version that I'm working on here, they've changed the remove at index function to just this function, the remove, and then we give this argument here at equals 3. So this is equivalent to what the previous was, remove at index 3. So you'll see this from time to time with languages. Now, some of your old languages like C and C++, that's less likely to happen because many of them have been around for 30 or 40 years, but Swift is still a young language. If you remember, it's less than 10 years old and they're still kind of feeling things out what they want to do. And so this is a change that they've made. And they must have made it a couple versions ago because we're not getting a warning anymore like what we got earlier with the function, the flat map versus the compact map. That's not there anymore. Remember, it warned about that, saying that, hey, this is going to go away. So this, they probably threw out a couple versions ago, and now they finally did it. But these still work. They're remove last and remove first. So we can use this, remove, and then have the print array and an example array. I'll try to go into the notes and make this change. That way you don't see it. You may look at this and go, well, what's going on? This is why, is because I'll go in and make those changes to the notes. And it'll be a little less confusing then for students that may not, that just look at the notes and don't look at the video. So that's pretty much it for today. We need to explore a little bit and see what happens. Hey, let's try this, let's try that, and see what works, see what doesn't work. That's the best way to learn how to program. The best way to learn little things about the language is be curious and just see what happens. All right, I want to thank you for watching this video. I really appreciate it.